Hello, good morning, everybody, and welcome from Hilversum, the Netherlands. Welcome also at the Collaboration Days, organized this year by the BWUG and the DWUG. My name is Hessing again. In this session, we talk about Power Platform architecture. First, a big thank you to all the sponsors. Without these events are not happening, basically. It is that simple. Even though we're now in online conferences, still all the support from these sponsors is really appreciated. So during the day, I think there are quite a lot of videos on the website of Collab Days. So please have a look at them and know what they are doing. I am Donald Hessing. I work for Capgemini in the Netherlands. I'm the Digital Customer Experience Lead within the Microsoft team. I was also the program chair for the last couple of ESPCs. And again, if you want to reach out to me, my Twitter handle is @Hessing. So what are we going to talk about in this session? We will have a short problem statement of what we had with citizen developers, power users, low-code platforms, and how that fits the overall architecture. Then we dive into the Power Platform components, things like connectors, common data servers, some performance challenges and throttling limits that come along with this platform. And then we dive into how you can extend the platform with your own UI components and make it part of a release train by using the Power Platform tools for ALM. All right, so why is Power Platform a low-code solution so gaining at the moment? And what we see is that IP application development is really moving towards a low-code, high-productivity platform. Gartner predicted that in 2024, about 65% of the total applications will be developed in low-code types of solutions. I think Satya Nadella talked on top of that this year, is that he expects that about 50 million applications will be built over the next 4 years. So that's more than all the applications that we have built over the last decade or so. Now, what all these applications have kind of in common is that they have an essential part in terms of connecting to existing data sources. So if you look at these businesses these days, all enterprises have a CRM, they have an ERP, they have a PIM system for master data management, and so on. And by utilizing these low-code platforms, you can directly tap into these data sources and build business processes around it that maybe are too complex within the core system, or where they want to have a specific use case for a user that is more tailored to his persona. But let's take one step back, because these citizen developers or power users, that's not just from day one, right? So we have a long history in terms of these productivity tools. Back in the days, we probably all remember Microsoft Excel, VBA macros. For those that are in the SharePoint domain, we had InfoPath with SharePoint Designer, and still a lot of Access databases, either with or without SharePoint. Now, the reason why these tools became so popular is that it allowed the business to develop these applications themselves without the dependency of IT being involved there. So no need to have challenging discussions with security or capacity in the data center or acquire the right licenses. The business had the power. The other reason what we saw is that the business had their domain knowledge, and if they need to have IT, they had to write down the requirements. Then the IT guy picked it up, and then he built something that, hopefully came close to the requirements, but quite often, there was a significant gap to what the business wanted and what IT created. So with having these tools at hand, it was really beneficial for the business to directly develop something that they needed. But what is the problem with these types of solutions? Well, if you look at how these applications evolve, typically they started with a very small application scope that often satisfies the requirements with the tool. But then additional requirements came in, and the implication became hard because the tool didn't support these edge cases. And to implement these more complex or non-trivial use cases, significant code had to be written, and that was quite often in a niche area of the tool, which made it hard to maintain and support. The other challenge that we often see is that there's no what we call three-tier type of architecture. So a lot of the business logic is being built in the front-end layer, either with JavaScript or with rules-based types of logic, which results in hard to maintain. And if we want to build an additional client on top of that, let's say we want to have a mobile client on top of that, it's really hard to connect because we need to duplicate that business logic as it sits in the front end. Now, some of these applications became really, really popular. And the challenge with being popular is that you need to scale in terms of performance and sizing, both from a data perspective as the amount of users. But these tools were not designed to scale as such. So just remember, back in the days, we developed Silverlight applications with a Excel sheet being connected or stored in SharePoint. And then, the amount of connections that need to be established to that Excel sheet became quite quickly a challenge and a bottleneck. So you need to have, let's say, an architecture and components that can scale with your success. With success also comes the need from IT in terms of visibility, not only to maintain it, but also to ensure that the data sources are secure, that the data is stored in a location that is compliant with things like GDPR regulations and so on, but also in terms of having multiple applications serving the same goal. I recall I worked for a large brewery. They had a great Lotus Notes environment, but they had like 70 holiday leave request applications being built each in every country. They had the same. So there's a clear need, to make that consistent and have a more enterprise scale solution. Now, the ease of connecting to these data sources, and you will see that with the Power Platform as well, allows you to quickly create something, but it also comes with a challenge in terms of data consistency. So, for example, if you connect to multiple data sources, in one data source you store maybe table data, and the other data source you store blobs or you store documents, then how do you keep these data consistent? Let's say if one connection fails, for example. So transactional or relational data often comes with that challenge. And then lastly, if we want to move to a more enterprise-grade solution, then quite often it's hard to get the data out of that system. So what are we looking for is basically, a low-code platform that supports more of a multi-tier architecture where we have front-end, business logic, data layer, and where we can share that business logic so that if we want to extend to multiple clients, for example, we have an endpoint that goes through the business logic back to the data layer. But also an architecture that allows you to extend to where the low-code platform stops to support the more challenging use cases. And ideally on a technology that is well known by the developers and also maybe within the Azure ecosystem. And lastly, we would like to have a solution that can be governed by IT to prevent things like data silos. Now, some of these challenges can be fulfilled with Power Platform, and during the next couple of minutes, I would like to walk you through how you can do that with Power Platform and give you some angles in how to set up Power Platform at your enterprise. First, I think it would be really essential to have a good understanding of your low-code platform. So have a well understanding of how Power Platform works is key to understand and make architectural decisions. Now, the Power Platform has a layered approach. So you can connect from Office 365 or Dynamics 365, or even build your own application on top of it. So it's up to you if you want to connect your own, let's say, React or Angular application to the OData service that's being provided by the Power Platform. You're free to use that. The key components of the Power Platform, and these are kind of changing every other month at the moment, is the Power Apps being your front-end application layer, having business logic or process automation in Power Automate, and then the ability to bring in sophisticated business analytics or reports within your solution, and lastly support some virtual agents in your application. Now, they all share two important aspects, and that is the data connector and the capabilities that are behind it, things like AI or Azure components. Now, to step into how you connect to the data, two flavors. You can either use one of the 300 plus or so data connectors, or you can use the Common Data Service. And we will talk about more on Common Data Service later on. But basically, it's a service that brings a set of data capabilities, but also the ability to extend and add business logic by, for example, creating a webhook to an Azure function. So when we build Power Apps, you need to choose whether you're going to build a Canvas app or a model-driven app. The Canvas apps starts with a user experience first type of approach. It's a WYSIWYG designer. It's more for pixel perfect type of applications, and you need to choose whether you go for a mobile client or a web client experience. So it doesn't come with responsive design out of the box, but you can mesh up your data easily, or create mashups with data from around 200 plus data sources. The other side of the spectrum is model-driven apps, quite common and popular in Dynamics world, where you can build on top of a common data service with existing data model and start your application by using that data model and the relationships it has with entities. So these applications are more data-driven, so to speak, and they come with business processes to support your application. Now, Power Platform doesn't stop with citizen developers. And I think one of the great areas that Power Platform is now going into is to have the support for pro developers as well. And pro developers can use their own set of tools that they're used to in their day-to-day job. So where citizen developers or low-code developers can use the Power Platform or Power Apps to build front ends or business project logic in Power Automate, the pro developer can build more advanced either business logic or create their own connectors by using their tools of choice. Now, the good thing is that these are, they can use their Azure PaaS services that come with the security, that come with the scalability that you expect of those services. So, when you get the success, you build on a platform that can scale, but also provide you the layers of security that you typically need. And connector is a key component of the Power Platform. So whether you're in Power Apps or let's say Power Automate, you want to connect to a data source. And it comes with a broad set of connectors. So that's not just, let's say, the Azure services, but that's way beyond that. So if you want to connect to Salesforce or Twitter or whatever SaaS service is there, I think there basically is a connector for. If there is something that is not supported or you want to have more control, the pro developer allows you to create a custom connector that then can be used by the citizen developers to connect to your data source in the way you have designed it. Lastly, you can create composites, so you can join data sources. So if you would like to have a data source to your SQL database, but also fetch Twitter data because you're running a conference app or whatever, that's basically your choice. Important to understand if you work with connectors that there is also there's always a performance implication. So depending on the query that you do to your data source, there is obviously a processing time in the data source. But the total time is not just the time it sits in the data source. There is some additional overhead because of the scalability and the performance and security layers that the Power Platform brings in. So typically, if you build a connector, or a connector is basically an OData API endpoint that's being published by Azure API Management. So if the Canvas app or whatever app connects to the connector, it first goes through Azure API Management. That takes care of the security layers, but also things like throttling. So there is a bit of server overhead there. Then the call is being made to the actual implementation of the connector, so the OData servers. That translates the request into a request to the data source. The data source, that's where the majority of the time should be. So that's retrieving the data, and then the connector needs to process the response from the data source back to an OData response, back to the API management layer. So keep that in mind that when using the connector, specifically if you have performance challenges, understand where this sits. If you're using the API gateway, there's actually an additional layer, and that quite often is a cause of performance problems because of the health of the API gateway. So keep in track of where the time sits if you face any of those challenges, and understand whether it's a limitation of your custom connector, of your connector, or your backend data source. Now, be very careful when you select your data source or your data connector, because there's a variety of data connectors out there, and each support a certain goal and comes with certain capabilities. So things that you need to ask yourself is, what is the purpose of your data? What the type of the data is it? Is it a relational data where you have entities linked to each other, where you want to maybe have a relational integrity? Is it more transactional data? What type of data is it? Is it personal sensitive data, yes or no? Is there any GDPR implication there? And is it just relational data, or do you also want to store images and documents? And how do you keep the relational data with the images and documents in sync? And another one is IoT, that is getting a lot of traction, specifically with the low-code platforms when you want to have IoT data being published as reports in your application. So keep all that in mind. Where is my data stored? Is the data source using maybe a cloud service that sits out of my region? When we have implications from GDPR or security, does that support my type of data? Is it only relational data, or do I need to link to documents and images? And how is that being maintained? Then is the data source or connector designed my expected load? So can my connector and my data source scale to the need that I want? And how is that being secured? Some of the connectors can support some sort of business logic, so that would be good to understand. And from a performance perspective, is there caching on the connector layer, or is there any throttling? And how does it deal with throttling, for example? So some guidance for using the Azure API layer. One thing I really like is the Azure API or the API gateway to use, because when creating connectors based on the API, you have more control on building the business logic. It supports more of a three-tier model, and it's more loosely coupled to the data source. So if you need to scale to a different data source, this is the place to be, because in your own API, you can later on abstract the data source and move and connect to another data source if you like. The actual implementation of the API, if you host that on, let's say, things like Azure Functions or Kubernetes cluster, whatever you prefer, you have the ability to scale along with the success of your application. Azure SQL or SQL Server is really good for large data volumes and transactions. But if you need to support things like blobs in relation with your relational data, then there's some limitations in storing that blob, specifically if you want to do things like searching in that data as well. Azure SQL or SQL Server also gives you some support or can help in scenarios where you have to one-end query problems. So let's say for every person you want to query also the owner, or for every asset that you have, you want to query the owner, and these are two tables. That's typically a lookup to the second table. If you model that not correctly in Power Apps, then it could be that for every asset there is an additional query to the assets. That quickly can give performance challenges, and views here can help to abstract that logic. SharePoint and Office 365 from an history is a popular data source. I always say be careful with that, because where you store that data, it quite quickly becomes hard to maintain that data source. So if that's a list, for example, it sits in a site, who has access to that site, what is the structure of the list, who can change the structure of that list, quickly has a connection with how you model your app. So be a bit careful there. Also, SharePoint Online and Office 365 comes with throttling. So everyone who did a migration to SharePoint knows that. So keep that in mind. SharePoint is fine for storing documents and things like that, but I wouldn't use it for things like storing list data or relational data. Dynamics for customer engagement is a great candidate. It comes with the Common Data Service, so there's a native connector for that. It comes with predefined entities, and it supports a 3D business logic. So if you want to build an application that already contains some of the customer engagement type of entities, then this is a great candidate. Very popular in demos is using Excel as a data sheet, quite often being stored in a SharePoint site or somewhere. Great for demos, but it has limitations on the size, it has limitations on referential data, and the number of transactions that you can do or connections you can make to that Excel sheet quickly becomes a bottleneck. So I would heavily recommend you not to go into the Excel and SharePoint domain, only maybe just for documents, and use a real enterprise scale data source for any serious application. Now, as I stated, Azure API management and building Azure APIs is really a trend that we see. It also comes with the API first strategy that many enterprises have, that starts with their consumer world, or creating APIs for their actual products and services. But you also see that now happening within business applications, so internal applications, so that they create APIs on top of their existing internal systems, so that you can build productivity apps on top of it. Really, really great, and it's an easy way to connect from a Power Apps or Flow perspective. Then the next flavor is Common Data Service, and the Common Data Service gives you much more capabilities than just a connector. So Common Data Service is basically a service which has a variety of components that you can utilize by building your application. So it comes with the web server to render and process your requests. It comes with sandbox environments where you can run trusted code. It has, for example, Azure SQL for relational data. It has Azure Blob Storage for your documents. You can store your log data in Cosmos DB. If you make your field searchable, Azure Search will be used to index your relational blobs. And if you want to do or implement more advanced logic, you can even have events or webhooks to an Azure function or being published to a service bus or event hub. Now, this is all packaged as a service and kind of abstracted for you. So the moment you create a common data service, this is the ecosystem that you get. The other benefit is that there is high availability and disaster recovery and things like that being baked in. So a common data service is being provisioned in a region and it's mirrored within at least 2 regions. So that comes with skill groups automatically and is paired with the other region. So great from an availability and scalability perspective. The common data service has a less overhead than the connector model. So there is now a native connector for CDS. So if you have built applications on top of CDS, please check whether you're using the native connector, because there are significant performance improvements with the native connector. The common data service implements basically the common data model, and the model is a variety of standard entities for common entities used within in systems. So examples can be how is being a customer or a product or a lead or an order. So all of that, there's predefined entities, and Microsoft is heavily collaborating with other partners to have this common data model being implemented along the common systems of Microsoft. So they collaborate with Adobe, they collaborate with SAP, so that you can interoperate basically the data between those systems. That basically means that if you build a solution on the CDS, the only thing that you need to do is load your data into the CDS, and then you can run your application. So how can we decouple the complexity? What we want to do in an enterprise scale application is not to have the business logic in the front end, but have that sitting within a service, so that if I build, let's say, a mobile client or another client, it sits within that pipeline. So it goes through my business layer and then to the data layer. And the way you can extend that with the common data service is at a variety of hooks. So we can use things like manage your trusted code running on the sandbox. We can have things like webhooks being registered as a plugin, so that if something happens on an entity, for example, a webhook is being called, and the implementation of the webhook can be, for example, in an Azure function. And that's the place where you can do more advanced processing, maybe business logic, or do call-outs to cognitive services or to any other system that you want to utilize as part of your business application. There's also things like batch processing and async handlers. So this can be either synchronous or asynchronous. My recommendation generally is if you can do it async, then please do it async, because that heavily increases the scalability and the performance of your application. Another area where you can extend is by building reusable components. And the Power Platform or Power Apps comes with a component framework where you can build your own UI components and then publish that within Power Apps, so that citizen developers or low-code developers can utilize these components to build their UI and logic around it. And pro developers can use basically their tools, so they can use HTML, CSS, TypeScript, React type of solutions. They package them, they upload it to the Power Platform, so it becomes available within Power Apps. You can also use your own APIs as part of that, and you have access to things like device features like camera or the location and the microphone. There is a great library already, which is the component framework gallery. The link is below in the screen, where you can directly access some of the components that have already been built. Within Capgemini, we have around 200 components at the moment being built and made available towards our citizen developers. And that can be either styling or more complex UI scenarios for which there is no component at the moment. But yeah, because this is all based on standard web technology, it's relatively easy for, let's say, front-end developers to develop such a component and make it available to the Power Platform. I have a short demo for this, so let me quickly go to my demo. I've recorded that because I know I need to be conscious of time, so let's have a quick demo on that. So here what we have is the Power Platform component framework. Let me quickly check if everyone can see my screen. Yeah. So what we here have is the Power Platform component framework. It comes with a couple of CLIs specifically for the component framework that gives you this shell for creating the components. Well, I'm not going to deep dive into the complete solution, but I'll give you a quick walkthrough. So here, in the index.typescript file, you have basically the component framework logic. There is a reference to the implementation of the rating control that we utilize, and we basically instantiate the simple rating control. The rating wrapper is the actual logic. It's being used by using Material UI. And here you can see that we basically have the logic of the control, we have the labels being defined, and we create the control and add it to the div tag. Then we have the manifest file. The manifest files says, okay, what is my component?
Donald, sorry for interrupting you. Can you just maximize the font a little bit, because people are asking for it because it's really fuzzy. Thank you.
That's a bit hard because it's a video.
Yeah. Or can you zoom? Or
I don't have zoom. No. I don't have anything like magnify. Yeah, I don't think Zoom works with video, right? Let me walk through because there's not a lot of code. So let me, I will do the voiceover and make the video available. So the first thing you do is we run npm install for loading all the dependencies. Then we do the run build, which builds the actual component. And then lastly, we will run the solution, which loads the component framework shell or test client. So you can run it on localhost and test it locally. And then that will run in a moment. So let's start the package, which will start up at localhost. So for this, you need to have Node.js as your server. So here you have the Power Apps component framework. You can see the UI control. You can see on the right-hand side the rating properties that you can data bind to your own data context. And the next step basically would be to publish this control to Power Platform. Now there's a couple of steps to do that. First, you need to create a project in Power Apps. So for that, we build a solution and then we package. We say we create a solution in Power Platform and then we publish the solution to Power Platform, or to Power Apps, I should say. Now there's a couple of more steps than just pack solution. I will provide a link for the complete walkthrough, but just for the sake of time, this will publish, we will create the solution, and then finally we will publish the solution. Once it's published, here in Make Automate, we can create a new Canvas app. Again, for Canvas app, you need to choose whether it's a tablet or a phone. And then in my Canvas app, I can go to my components and make them available in my gallery. So I insert, go to custom components, import the components. Because I've published it in my project here in the code, you should be able to find my rating control. There it is. And then we say import, which makes the component available on my in my gallery. And now I can drag and drop the component on my canvas, and now it has the same behavior as what I showed in my test environment. So this is a very, very simple example, and you go completely crazy with that. If you want to kickstart, there is quite a lot of components available. So what we did is this is the rating control that we took from Material UI as an example. There are, well, lots of components. I think Capgemini is contributing to this as well. Yeah, so a lot of large enterprises using these components and contributing to these components. But again, it's free to build your own components, and we'll build that wrapper and publish it as a component within Power Apps. All right. The other important aspect of enterprise grade deployments is to have a CI/CD pipeline ready to bring your Power Platform components from, let's say, a test environment to a test environment, and in the end to a production environment. This always has been a challenge because of the connections and the way the components have been built. Now, there have been some slight improvements over the last couple of months. Microsoft created the Power Platform tools for Azure DevOps. That gives you a couple of actions in Azure DevOps to support this. For that, we also have a quick demo. So let's run to my other demo here as well. Hopefully, this is a bit better. So what we here have is two pipelines, one for the build and one for the continuous integration. We deliberately don't call it continuous deployment because there are still some manual steps to be done. We already run the build pipeline to speed up the demo a little bit. We have two environments in Power Apps. One is the test environment where we have the application, and the other one is an empty environment which doesn't have our application being deployed. It's just some trial solutions you see there. Back to the Azure DevOps pipelines. So the build pipeline is already run. That takes some time. So let's run the CI pipeline to deploy our solution to the test environment. And while that is running, let's have a walkthrough of how to set up the build pipeline. So if you look at the build pipeline, the first thing that you need to do is install the Power Platform tools. There is a latest version. You can see that you run it against the Windows agent here. But if we look at the Power Tools installer, then you will see that there is a new version, and that new version has some new capabilities that we want to utilize, right? So things like connection references, but also the way you can set up the service principals between Azure DevOps and Power Apps. So the actions that we have, we first export the solution. For that, we need to use the service connection, which is a service principal that we need to define. And that service principal is defined in Azure Active Directory. So we need to register the application there and define the service principal that we can use within Azure DevOps. So here's our service principal for the dev, and then later on we have another one for the C, for the test environment as well. So this is the service principal that we use to connect to the CDS. Then there's the Power Platform Checker, which allows you to do some questions or no. Then we have the Power Platform Checker that allows you to do solution validations. You can configure the error level, for example, and the threshold, and if there are any errors we want to stop. And finally, we can unpack the solution and run a Git command. Then to the pipeline, we have one job running still. You can see it's still not finalized yet. We can see in the checker that it performs all kinds of checks. Now this is simple solution, so there is no issues in terms of count or critical issues being defined. In the solution, you can see that there is app modules, we have entities, we have a Canvas app, there is a flow being defined as well. And in the relationships, that's an important part where we can look at how the relationships are being tied together. So we have a flow that sends an email that connects to Office 365. So here you can see the connections being referenced. So that now with the new actions come along, unfortunately, we cannot change the actual connection setup. So the connection string is still something that after the deployment is something you need to manually update. Similar for the pipeline, so we need to install the tools, we need to pack the solution, we need to import the solution to the test environment, and then we want to publish the artifacts in artifacts in Azure in Git. Here we have the service principal for the CI environment. So again, the two service connections that we have defined, one for the CI and one for dev. And while this is still running and deploying to our test environment, let's have a look where it is in the process. So once it is finished, we want to typically publish this to artifacts so that later on with a continuous deployment pipeline, we want to pick it up there and deploy it to, let's say, production. So the pipeline is still running, the continuous integration pipeline. Let's see where it is. So we can still see it's importing the solution. Now, as you can see, this is quite a simple solution, but it's still not there in our test environment because it's still importing. It's a simple solution, but still takes quite some time to actually import. And I expect in a couple of seconds this is done. So then now the solution is being imported and we publish it to the artifacts. So if we would go to Power Apps and see if our solution is actually being deployed. So Power Apps here, let's refresh it, and then we should have our Power Apps demo solution. There's our Power Platform demo solution. That contains the model-driven app, the Canvas app, and the flow for sending email as well. So now you can see there's a successful deployment. These were the flows with the connections. So these connections come along, but we still need to set the data connections or the principles for connecting to the Office 365. Or maybe to your test database that you need to set the connections again. So that's it for this demo. But Power Tools now allows you to, so the Power Platform Tools now allows you to use that within CI/CD. Back to the slides, a couple of minutes on performance and thresholds. So what we typically see in terms of performance issues is that the Power Platform takes into account throttling. So be aware of the number of connections that you make. It's that because it's a multi-tenant environment where multiple clients connect to that environment. So keep that in mind, keep throttling in mind, accept that you can get an HTTP 429 to many requests, and factor that into your application. Specifically, if you're using the API gateway, check the health of that. It's quite often a bottleneck. Check your SQL environment, whether it scales where you need to. And please don't use Excel for any other than for demo purposes. If you're using lookups in your Power app, check the typical challenges that you have with the N1 plus N requests. So either use SQL views or cache it on Power Apps so that you don't need to do concurrent callouts to the data source to fetch up lookup data. Some key takeaways. Before you start with the Power Platform, please fully understand what the capabilities in the architecture is. And I think hopefully this gives some starting points. Keep enterprise architecture principles in mind and apply them to your solution from day one so that you can scale and if you have success both from performance and security perspective. If you have more complex business scenarios, consider accommodated service. It gives you that complete set of services, whether it's relational data, blob storage, Azure Search, webhooks to callouts and things like that for more complex scenarios. Start with implementing your CI/CD pipeline so that you can move your solutions from dev, test, and acceptance environments. And the Power Platform tools now gives you at least some improved capabilities to also take into account the connections. What we typically do, and we'll also see enterprises doing, is building a component framework on top of it so that they give a bit more power to the citizen developers. Well, where the pro developers can focus on the complex UI aspects of it. And lastly, keep an eye on your solution, monitor it on performance, but also set up some governance model to prevent that you have an exhaustive number of applications being deployed. So with that, I would like to thank you all for staying online. And have a lovely conference. If you want to reach out to me, please use my @Hessing Twitter handle. And thank you and stay safe. Bye-bye. If there are still any questions, I will stay online for a couple of minutes.
Thank you very much, Donald. So for the people that want to ask Donald questions, go to the channel that is created, CD-31, and there you can add more comments or feedback, whatever, to Donald's session. So thank you all, and see you in a couple of minutes for the next session.
Yeah. Thanks, Elio.
Thank you.
And quite on time, right?
A bit. But we're not going to talk about that. Bye-bye.
The Omita framework is an enterprise-ready software platform that makes it possible to set up an easy integration between your existing back-office applications and push all the relevant information into digital workplaces. Omita has developed various kinds of solutions which can be easily deployed and linked to your back-office applications. Omita has solutions for contract management, HR to speed up onboarding and offboarding processes, sales dashboards, shop floor portals, and many more. If you want more information, visit our website.